Okay guys, I'm going to show you 3 quick graphs about how to graph a rational function. This is based on what we did in class, so hopefully you'll be able to put the things together that we've been talking about. So the first function that I'm going to look at is f of x equals 2x plus 8 divided by x plus 2. So when you're graphing rational functions, you have to think about a couple of things. You have to go through the steps here. So if you remember our steps from class, one of the first things you want to do is you want to completely factor it. So if we factor out 2, we're left with 2 times x plus 4 on top and x plus 2 on bottom. And you want to look to see whether anything cancels. And in this case, nothing cancels out. So the x plus 4 doesn't cancel and the x plus 2 doesn't cancel. So we can make our list of the characteristics that we're looking for. So first, the vertical asymptote. Vertical asymptotes, you should remember, come from the bottom. So we look at the bottom, x plus 2, and that tells us that our vertical asymptote is going to be x equals negative 2. Then we look at horizontal asymptotes. Horizontal asymptotes come from our rules. So remember your rules from class, bigger on bottom, bigger on top, or same. If we look at our original function, you can see that it's 2x divided by x. They're the same. They both have x's. So then we can just divide 2x divided by x and get y equals 2, and that's our horizontal asymptote. Next up, we look for x-intercepts. X-intercepts come from the numerator. They come from the top. So all we have to do is set the top equal to 0. So if we set the top equal to 0, 2x plus 8 equals 0, and solve, we wind up getting x equals negative 4. So that's our x-intercept. Make sure you write it as an intercept and as a point. Don't write it as x equals negative 4. Because if you do that, it looks like an asymptote. But in this case, it's an intercept. Then we do a y-intercept. The y-intercept comes from plugging in 0. So if I plug in 0 for x here, and I plug in 0 for x here, I'm left with just 8 divided by 2. That's 4. So we wind up getting 0, 4. And then the last thing we want to look for is, are there any holes? Remember that the holes occur when something cancels. Well, if we look at our original function, nothing canceled, so there are no holes, so we could say none. Now, once you have all these characteristics laid out, then it becomes pretty simple to graph it. So we make an xy table. We have a vertical at negative 2, 1, 2, so we draw a vertical asymptote. We have a horizontal asymptote at 2, so we draw a horizontal asymptote. We have an x-intercept at negative 4, so we can put a dot here. And we have a y-intercept up here at positive 4, so we can put a dot here. And now, based on the location of our dots, we know it's got to go through this point here. So that means it has to come along this line. It can't cross that line there. It's got to go through that point, and then it's got to go down here, and it can't cross that. Over here, if we extend our lines, it's got to go through this point, which means it's got to come from here. It's got to go through that point, and then it's going to go off in that direction. And that's your graph. I did it at a slant there, but that's your graph that you can look at. Okay, let's do one more. So I'm going to grab another slide here. So we'll do the next one on your worksheet, number 2. And this one is f of x equals x squared minus 4 over 2x squared minus 4x. So, remember the first step. We got to factor it. So up top, I'm going to factor, and I'm going to get x minus 2 times x plus 2. And on bottom, I'm going to factor out a 2. If I factor out a 2, it leaves me with x squared minus... Actually, I'm going to factor out a 2x. So let me erase that. I'm going to factor out a 2x, and that's going to leave me with x minus 2. So notice that the x minus 2's cancel. So then we're left with just x plus 2 over 2x. And that's what we're going to graph. So let's make our list. First we need a vertical asymptote. Vertical asymptotes come from the denominator, so we look at the denominator and we notice that x can't be 0. So that's our vertical. Horizontal asymptotes come from our 3 rules, bigger on bottom, bigger on top, or same. If I look back at my original function, I have an x squared and an x squared, so they're the same. So then it's going to be 1/2. Y equals 1/2. X-intercept. The x-intercept comes from the numerator, so I look at my reduced function, and I solve for the top, just the top. X plus 2 equals 0, so I'm going to get negative 2, 0. The y-intercept. The y-intercept would be if you plug in 0. Well, here's the problem. If I plug in 0, I wind up getting 0 plus 2, which is 2 divided by 0. But I can't divide by 0, so that means there are no y-intercepts. It's never going to cross the y-axis. And finally, the hole. The hole in this case occurs at 2, because if you look back at your function, x minus 2 cancel. So we have a hole at 2, something. We need to figure out what that something is. We have to plug it in. So we're going to take the 2, and we're going to plug it into the reduced function. 2 plus 2 is 4, divided by 2 times 2. It winds up being 4 divided by 4, which is 1, so there's a hole there. Okay, and so now we can graph this. See if I can do it straight this time. We have a vertical asymptote at 0, so I'll just try the best I can to make it 0. And a horizontal at 1/2. Let's say that's 1, so then 1/2 would be right there. An x-intercept at negative 2, 1, 2, so put a dot. No y-intercept, and there's a hole at 2, 1, so 2, 1, there's a hole up there. So now we just need to fill out the graph. We know it has to go through this point, so that tells me it's got to come along this asymptote, go through that point, and then go down like that. We also know it's got to go through this hole, so it's got to come along here. It gets to the hole, it skips over the hole, and then it keeps going in that direction. And that's what it looks like. Okay, so what I'd like for you to do, I gave you a third one on your OneNote worksheet, and so I want you to see if you can do the same thing for the third one that I just did for these two, and then tomorrow we'll come into class and we'll talk about it. All right, good luck, guys. I'll see you tomorrow.